This meeting is being recorded.
So in this lecture, we are going to discuss one more Boolean equation and we will implement that and we will design a layout using CMOS and also we will go for its stick diagram representation. Okay, let me share the screen. Screen दिसते का?
Yes, sir.
Okay. So we'll go for this equation. Okay. Okay. A plus B dot C plus C dot plus D dot E. Okay, fine. Now again, for your sake of understanding, okay, I will specify a rule here for dot and for the addition. Okay, this is PMOS. This is a NMOS. Can anyone tell the rule?
So in dot is there and PMOS is there, then they are in parallel.
Okay, and in case of add operator, it is in
Series.
series, and exactly reverse is the case with NMOS. Okay, so you have to remember this. And again, I told you already. So this PMOS, right? This PMOS is nothing but your pull up network of your CMOS that forms the PUN, that is pull up network. And this NMOS, right? This forms the pull down network. Okay, remember. Now we have to implement this equation. Okay, so quickly start with this. So this is VDD. Now tell me A plus B, right? So first we are going to implement this pull up network and then pull down network. Okay, so in case of pull up network, that means PMOS, if there is a add operator, then it should be connected in series, right? It should be connected in series. It should be connected in series. So this A and B, right, we will connect in series. this is A, B. Okay, and obviously it is connected to the VDD. Dot C, right? So to this A plus B, and in case of PMOS, this dot has to be connected in parallel. So we have to connect this C parallel to this A plus B. It is C. Next, now this we have implemented this first part. Plus, so in case of PMOS, this plus means in series. So this remaining part we have to connect in series. D dot E. So again dot product in parallel. That means now to this D dot E we have to connect in parallel. This is E and this is D. Clear with this? Now this we have completed this pull up network part. Okay. Now we have to go for pull down network part. Okay. Now again, after pull up network, always we are taking a output. So this is a output. And now we have to go for this pull down network part using NMOS. Okay. Now tell me, in case of this NMOS, and if it is an add operator, so we have to connect that in parallel. So this A and B should be connected parallel. Okay. Connect this in parallel. This is B and this is A. Clear? Now this remaining dot C. So in case of NMOS, dot should be connected through series connection. So to this, we have to connect that C. It is C. Now again, plus. So plus has to be parallel. That means what? Whatever this part has to be parallel with this A, B, and C. Right? So we will do that. Okay. Now this D dot E. So again for dot, we have to connect that D dot it in series, but in parallel with this A plus B dot C. So here we have to connect this D dot E. This is D and this is E. And finally, it has to be connected to ground. Okay. Clear with this? Now we have to go for its stick diagram representation. Okay, this is PMOS implementation. Now we have to go for stick diagram representation. But before going to that, we have to mark the terminals. Okay, so this is a source, this is also a source, this is drain, right? This is source, this is drain, and this is also drain. Now this is connected to this source, this source, now this drain and this drain, because from drain always we are taking the output, right? Then next part, this will be a drain because we are taking output from the drain. This also will become drain. This is source, this is drain, this is source, this is also source, right? This is drain, and these are the source, and this is also a source. Okay, now we have marked the terminals. Now we have to draw its equivalent stick diagram. Okay, so how to start with the stick diagram? First, let us mark the VDD, right? Let us draw a line for VDD and ground. So this is VDD and this is the ground, right? Then we have to draw a P diffusion and and N diffusion. So P diffusion, by which color we are representing a P diffusion? By which color actually we are representing a P diffusion?
Yellow color, sir.
Yellow color, very right. So it is P diffusion. I can simply write P plus, that indicates P diffusion. And by which color we are representing N diffusion?
Green
By
color, sir.
green color. So it is N diffusion. Now we have to mark the inputs or gate, because we are actually giving the inputs to the gate only. So these are the gates. So how many inputs we have? A, B, C, D, E, 5 inputs. So we have to draw such a 5 lines. 5 lines by red color, because we are representing the inputs by red color. First one, second, third, then this is fourth, and this is fifth. Okay, now see, I have already worked out on this, and I have finalized the terminals. Okay, but in your case, if you are doing this for the first time, then you have to go for some trial and error method. Okay, to decide which one you should, or to decide the sequence of the inputs, right? So it is not the case that always you should put the sequence as a B C D E. You can change the sequence depending upon your easiness and convenience. Okay, so I have decided the sequence as a, this will I consider as a B, this will be A, this is a C, this is a E, and the last one is D. Okay, so first one is a B, A, C, E, D. Okay, as I told you, see, a single CMOS circuit may have a multiple solution for stick diagram. Okay, so the single CMOS circuit may have multiple solution for the stick diagram. You have to remember this thing. Okay, now again we have to decide the terminals in this case also. So this will, I will consider as a drain. This is a source. This is a drain. See why I have chosen this, that I will explain bit later. While joining the connections, I will choose the logic behind how to decide a terminal. See, while deciding terminal, you have to make note of one thing. Whatever the common terminals that you have to club together, right? Whatever the common terminals that you have to put together, so that there will be a easy to connect that to a next part. Okay, इथे ह्याच्यात टर्मिनल किंवा या लाईन्स चूज करताना एक रूल लक्षात ठेवायचा की हे जे कॉमन टर्मिनल्स आहेत, जसं की या ए चा सोर्स, नंतर या सी चा सोर्स, किंवा या बी चा ड्रेन, या सी चा ड्रेन, हे कॉमन टर्मिनल्स आहेत. तर ते असे अरेंज करायचे की जे तुम्हाला कनेक्शन करायला, और टू कनेक्ट विथ दॅट, और टू अ नेक्स्ट पार्ट. नेक्स्ट पार्ट म्हणजे कुठला? हा डी आणि ई चा. तर नेक्स्ट पार्टशी कनेक्ट करताना किंवा त्या इंटरकनेक्ट करताना तुम्हाला ते इझी गेलं पाहिजे, अशा पद्धतीने हा सिक्वेन्स तुम्ही डिसाइड करू शकता. राइट? So first I will mention the terminals, then automatically you will understand why I have chosen this sequence. Right? Now again this is a source of C, this is a drain of C. Then again this is a source of D, this is a drain of D. This is drain of D and source of E. This sequence I have decided. Now let us go with the connection part. Okay. Now the source of A and source of C. Where is source of A? This. Where is source of C? This. That we have to connect to this VDD. So here we have to connect this source of A and source of C. Now we have finished with the disconnection. Now drain of A, this drain of A is connected to the source of B. Yes, it is already connected through this line. It is on a same line, right? So you need not to connect this part. Now the drain of B and drain of C, right? Drain of B and drain of C, this is a drain of C, it is combined together. But this drain of C, it is also connected with the source of E. So it is already connected with the source of E and source of D. Where is source of D? Here is source of D. That means this drain of B, you can combine here and also here. Now we have connection with this entire part. Now where to take output? From drain of D and drain of E. Now you can understand why I have chosen this sequence, so that you will get certain terminals close to each other, right? I have clubbed certain terminals so that I have to draw a single connection from there, and we have to connect to the next region, right? You have to draw a single connection from there and you have to connect to the next terminal, right? So from this drain of E and D, we have to take the output. This is output. Okay. Now we have finished with this pull up network part. Now we have to connect this pull down network part, right? We have to connect this pull down network part. Now here also we will maintain the same sequence. Okay. Here also we will maintain the same sequence. This we will consider as a B, this as a, then this as a C, this as a E, and the last one as a D, right? Now, again, we have to mention the terminals. Okay. First, now again, I will write the terminals, and then while connecting, I will explain why I have chosen such a terminals. And while we have performing the practicals on that micro wind, I told you, right, in that we have one freedom on the both side of this polysilicon. Either this or this could be selected as a drain or source. That means there is no such a hard and fast rule that you have to select always left hand side as a drain and right hand side as a source. No, you can interchange that up to your convenience and easiness of the design. You can select the appropriate terminal, right? You can select this as a source, this as a drain, or this as a drain, this as a source. For the A also you have that liberty. For a single MOSFET or single PMOS, you have liberty to select either any of the terminal as a drain and any of the terminal as a source. You have that freedom. Okay. So let me mark the terminal first. This I will consider as a source. This, but obvious, this will be a drain. Now again, this will be a drain of A, then it is a source. Now in case of C, again, I will consider this as a drain, this as a source. In case of E, this will become a source, this will become a drain. In case of D, again, I will choose this as a source, this as a drain, right? Now, we will go for the connection. Now coming to this part. Now, first of all, the drain of A, then drain of B, and drain of D. We have to make common, and we have to connect that to the output, because these are the on a same line, that is short with each other, right? So you can say this drain of A, drain of B, and drain of D, you have to connect it to the output. So where is now drain of A? Here it is drain of A. Where it is drain of B? Here it is drain of B. And now you can understand and realize why I have chosen this drain on the same side, because you can connect it with the output very easily. Okay. Now we have to connect this to the output. Fine. Now this output is also connected with the drain of D. Where is the drain of D? Here is a drain of D, right? Here it is a drain of D. Right? So you have to connect that part. This drain of D is to the output also. So here is a drain of D. So this same you have to connect to the output, right? So here you can extend this drain of D. Next, we have finished with this part. Now source of A, right, and source of B, it is connected with the drain of C. So again, this source of A, right, and source of B, source of A, it is connected with this drain. So this already source of A and drain of C is on same line. So we need to just connect here, right? Then the source of D, this is a source of D. It is connected to the drain of E, right? And the source of E and C, it is connected to the ground. So here you have to connect this to the ground. And this drain and source of D&E, it is on the same line, right? So you need not to connect any separate connection, right? So now this is your entire design. Okay, so this drain is has to also connected with the output. So this drain of A, B and D, it is made common and connected to the output. Clear with this?
Yes, sir.
Okay, fine. So now I will give you one Boolean equation U for the homework, and what you have to do, you have to draw its CMOS logic diagram also and its stick diagram also. Okay, clear with this?
Yes, sir.
Okay. Okay, so now we have finished with the how to implement Boolean equations using CMOS logic and all that. Also, we have studied the stick diagram, right? That second chapter part also we have covered. So for this lecture, we will stop here. Uh, in next lecture, we will start with the remaining points of unit number 3. Okay. So for today, we will stop here. If you have any doubt, query, you can ask me right now.
No doubt, sir.
Okay.